Simple Visual Studio project. I've just got my main file here, which calls log. This is the log.cpp and log.h that we made in the previous video, in the video about C++ header files. What we're going to do first of all is we're going to set a breakpoint, and then we're going to step in Visual Studio. You can either just hit F9 and it will set a breakpoint on that current line of code, or you can click on this sidebar anywhere on the sidebar here. Just click once and you'll set a breakpoint. Obviously, if you do something like set a breakpoint on line 3, that's not really going to work because there's nothing on line 3 that's ever going to get executed. So make sure you set a breakpoint on code that actually will be executed, on lines that will actually be hit. So line 6, of course, will be hit because that's the first line of code in our program. And then all you have to do is run your code through the debugger. One tip is to make sure that you're in debug mode, because if you're in release mode, the compiler will actually change the way that your code looks, and your breakpoints might not ever get hit because your program has been rearranged. We'll talk more in depth about what release mode actually does and all that stuff later, but the gist is if you're debugging, just make sure you're in debug mode. If we then hit the local Windows debugger, which ensures that we're actually running with the debugger attached, our program will run, and you can see that the focus from our program is actually stolen back to Visual Studio, and we change into this kind of different alternate layout, along with a big yellow arrow on that breakpoint, indicating that that is currently where the instruction pointer is at in our program. The main areas to look at here are basically this continue button, which will continue executing our program like normal. And then we have a bunch of buttons over here that let us step into. Step into is going to step into the current function that is on this line of code, if there is a function. So in this case, if I hit step into onto log, we would actually step into the log function so that we could see what it does. Step over is going to step over to the next line of code in this current function. And step out is actually going to step out of this current function and take us back to whatever called this function, which in this case, since this is the main function, will be the C standard library. You can also use F11 to step into, F10 to step over. Okay, check this out. So we step into this function where at the very beginning of the stack frame, we haven't actually begun executing any code here. We're just setting up the function stack frame. We can hover our mouse over this message variable and check this out. It tells us that it's set to hello. Hit F10, it's going to bring us up to this line of code. Now, the fact that the yellow arrow is on this line of code means that it actually hasn't executed this line of code yet. It's on there, it's about to. As soon as we hit a button like F10 or Shift F11 to get out of the function, or F5, which will continue our program, as soon as we hit one of those, it's going to execute that line of code. And bring up my program right now, you can see that that hello world message has not been printed. But check this out. If I hit F10 and then check back, look at that. We've printed hello. Go ahead and make some more variables to make things interesting. I'm going to make an integer called a, set it equal to 8. I'm going to do a++, which will increment a by 1. So in other words, it will set a to be 9. I'm going to create a C string here by just typing in const char string equals hello. I'm going to write a very basic for loop here that's going to iterate through this string and print each character out on a separate line. And then I'll leave in my log hello world for good measure. So if I run my program with no breakpoints at all, just to see what even happens, you'll see that we get basically something like this, where we have hello and then hello world. Very top here on int a, and just hit F5. All right, cool, let's take a look at what a is. What? Why is it negative 858 million? What it's showing us is what the memory where a would be is showing right now. And since we haven't actually set that variable to anything yet, it's just uninitialized memory, which means that this value is just showing us whatever that memory actually contains. This would be a fantastic time to bring up these three important windows that we have here: autos, locals, and watch. Autos and locals will basically just try and show you local variables or variables that it thinks might be important to you. Watch, on the other hand, lets us actually monitor variables. So what I can do is I can type in a, which is the name of the variable, and hit enter. And you can see that it's showing me the value of a. If I also want to view what string is, I can also put that in, and it's going to show me what string is. Now, of course, we haven't initialized this memory yet, so currently it's completely useless, it's just garbage. But as we step through our program, these values will update to show what's actually. We go debug, Windows, memory, and memory 1, we're going to be greeted by this weird looking panel here that's going to show all of the memory of our program. So on the very left, we see the memory addresses. In the middle, we see the actual data, the actual values represented in hexadecimal format. And on the right, we see the ASCII interpretation of those numbers. If you want to locate where this A variable actually is stored in the memory of your program, you need to know its memory address. And to do that, we can simply type in ampersand and A. So the ampersand in front of a variable name will actually get that variable's memory address. If we hit enter, we're going to be taken to the memory address of that A variable, which in this case is a programmer view. We can type in the hexadecimal value. If I just click on hexadecimal here, type in CC, and you can see what that value is in decimals. That this memory is a whole bunch of CCs means that it is uninitialized stack 10. A lot of things are going to happen. One other thing you can do actually in this watch window is right click and select hexadecimal display. And so now you can see that the value of A actually is a whole bunch of C's, which of course means that A is currently uninitialized stack memory. Let's go back to our non-hexadecimal display and let's hit F10, and a number of cool things are going to happen. So namely, in this watch window, our value has changed to A. It's also red, which indicates that it's changed since the last breakpoint. Our instruction pointer has moved down, which is showing that it's now about to execute. Memory view, you can also see that these 4 bytes of memory have been set to 8. By the way, I should probably mention that every 2 digits here is equal to 1 byte. That's also why we're viewing this in hexadecimal, because if we do that, every 2 hexadecimal digits are always going to align to be 1 byte of memory. So we can tell just by looking at this that these 8 hexadecimal digits are 4 bytes of memory. And you can see that in advance, this is now set to 9, it's set to 9 here as well. Pretty cool stuff. You can see that string is still uninitialized stack memory, but check this out. I'm about to initialize it, aren't I? So if I hit F10, it's initialized. Because this is an actual pointer, it's also telling us the memory address of that string. So if I was to copy this memory address here from the watch window and paste it into my memory view and hit enter, look at this, I'm taken to these bytes, which in this ASCII interpretation, you can see that it says hello. And what's really interesting is that if you actually keep reading, you can see that our program literally contains memory close to this hello variable that says stack around the variable was corrupted. The variable is being used. Real interesting here because we've run into this for loop. What's going to happen if I keep a program? You can see that I is set to 0. It's going to grab index 0 from this string, which is going to be the very first character in the string, which is a capital H. If we hit F10, we can hover our mouse over C and see that it's set to H. We can also come over here into watch and just type in C, and you can see we're now taking a look at what C is. When I hit F10, it's going to log that letter to the console. And then when it gets back to this curly bracket, it's going to run this comparison. It's going to compare, is I less than 5? And then if so, it's going to increment I and then jump back into here. So if I hit F10, you can see we jump up here to do the comparison. If I hit F10 again, we've done the I++, I is now 1. We're going to do the same thing all over again, except this time I is 1. So it's going to grab the second character, which is the letter E, and continue on. In this case, C is equal to E. You can see that it's changed here in our watch. If we come up here, do ampersand C and hit enter, you can see we have 65, which is the letter E, according to our ASCII view. Fantastic, I can keep running through this and everything's going to be great. Now suppose that I wanted to exit this for loop and maybe jump to this log function. I don't really care about stepping through this, I get how it works. How do I get out of this for loop? If I try and step out or hit Shift F11, it's actually going to exit the whole function. I don't want to do that. I just want to kind of keep running the for loop and then stop here. How do I do that? Well, it's pretty simple. All you have to do is put a breakpoint on where you want to stop next. And if I hit F5 or press the continue button up here, it's actually going to run my program until it hits the next breakpoint, which in this case is this log function. So by this point, you can see that the memory that used to make up this C variable is set to O. It's actually still active. That memory is still there even though we've gone out of scope, and we'll talk about that in the future. But the memory is set to the very last character of the word hello. And if we bring back our program, you can see it's printed up that entire hello word. And then we're about to execute this hello world log. If I hit F10, we're going to jump to the next line of code here. It's going to print hello world. Now we've actually paused execution of this program because we had a breakpoint here and I just hit F10. So if I press enter here, nothing's actually going to happen. I need to hit F5 and then our program will close because it is going to still detect